Breathe in harmony, breathe out discord. This is Answer Everywhere, a show where we, unencumbered by any sort of preparation process, dive into a code base and poke around and try to see what's there. Today, we are looking at Redux, the React framework library thing for managing state in your JavaScript applications. As a reminder, I am not myself a JavaScript developer. I've used React and I've used Redux a couple of times, but really only at the level of making a tutorial or an MVP app. So I suspect that most people watching this have more experience with JavaScript and React and Redux than I do. Nevertheless, we will jump on in. And if you are interested in these sorts of things, you might want to check out the video that I did on React. We've also looked at Flutter, which offers some of the same ideas with respect to state propagation. Flutter is another framework where the basic gist is that you have some tree that encodes your app, essentially the HTML document for things to go into the browser. And that tree, the nodes of that tree all have to have the same vision of state. And my understanding of Redux is it's about making it easy for applications structured in that way, in this hierarchical tree-based way, to all have access to the same vision of state. And the way they do it, as my understanding goes, is that there is a global bundle of state, a state object, that's really kind of serving the way an in-memory database is working. And then you essentially inject the database connection into any object that needs it. So this sort of pattern would be very familiar with Java developers since the dawn of time, which I think is basically the mid or early 90s. Java developers have been used to the everything's in a database, so you grab things from the database. And then at some point, dependency injection frameworks became very popular. And so the pattern was to inject a database handle or some sort of database access object wherever it needed to go. So Google did this with Juice. And then I think that maybe one way of thinking about what's going on with Angular and React and React Redux is that this pattern was essentially moved to Angular, originally as two-way data binding, and then kind of focused down on one-way data binding. And then the one-way data binding pattern became even more popular when Redux was released. So I think that's how it goes. I'm not sure. Let's make sure that I'm in the right Redux repo. I think this is it. I don't know how many Reduxes there can be with JavaScript. Redux is a predictable state container for JavaScript apps. It helps you write applications that behave consistently, run on different environments, client, server, and native, and are easy to test. You can use Redux together with React or with any other view library. It is tiny. And we've got this time-traveling debugger thing. I'm not quite sure how the time-traveling debugger is going to work, but I think the overall architecture is going to be actually pretty clear. Let's see if we can find architecture. Let's see if we can find a Redux architecture diagram or like slide. These kind of look like different graphs. I'm not sure which one of these is. This seems like maybe the standard graph. I'm not sure. Redux is supposed to be related to reducers, which is, you can think of as like a fold if you're familiar with functional programming. I'm not really sure which of these diagrams is authoritative. So here we have a state object. The store, I think, is the thing that stores state. We have a reducer, which, if I understand correctly, is essentially going to dispatch events and handle the need to propagate state. and everything comes from this database, I guess. And components, I suppose, subscribe to the store, and they dispatch thingies like events. And then there's might be some middleware, including Thunk middleware. I guess they're going hard with the functional programming metaphor. And then you've got reducers. And I think the idea of the reducer is to essentially, if you think about it from a control theory or maybe Kubernetes mindset, we have current state and we have new state. We're essentially getting diffs. So we're essentially subscribing to a news feed of what's changed. And so there has to be something that actuates upon the diffs that merges the old state with the new state. And I think that that's what the reducer is about. Maybe we will see that, maybe we won't, but that'll be kind of my working assumption going in. So I clicked on source. I'm not positive everything is source. Let's take a quick look at the top level directory. Source seems pretty thin. We have scripts, examples, logo, test, website. I'm guessing the website is the Redux website. I'm going to probably keep, I can already sense that I'm going to confuse linguistically the words React and Redux, partially because they're so closely bound in my mind. I know there are probably lots, or maybe some contingent of Redux fans who don't use React. But this is not my day-to-day world. So if I mess up, I apologize. Okay, so maybe it is really small. So we have types and we have utils. We have apply middleware, bind action creators, combine reducers, compose, and create store. Is that really all there is? What's in scripts? We can mangle errors. Let's see. So let's go look at create store. I'm not quite sure what compose is. I'm going to guess combine reducers is probably pretty fundamental. Bind action creators, this is going to do some sort of binding. That's probably essential, but maybe not so fascinating as far as reading code. Is there anything of a special interest in utils? I'm a little bit nervous this is maybe not the GitHub repo I should be in. So if you're watching this live and you know that I should be somewhere else, please let me know. But we'll dig into it more and see if we see pointers to indicate that we should be somewhere else, I mean. So in types, we have store, reducers, middleware, and actions. And that seems like, at least for a really simple Redux sort of thing, that seems like the right kinds of stuff. You know what? Here's one idea. If I'm concerned this is not entire, so React Redux is its own thing, which is the official React bindings. I'm going to guess that this might be even larger than the Redux library. But we're going to go with Redux. I'm just kind of curious if we peek in maybe source. Not much larger. Components, connects, hooks. What is components? Context providers. Okay, so maybe it's sufficiently simple that there's not too much to really worry about here. But I was thinking, if I'm not sure, I can at least look at the releases and then check it out against, I don't know, maybe Redux tutorial, like the top level result should be, let's say here. Let's see if I can find anything about version. Or GitHub. This is some other thing. Yes, I don't know. I guess I'll just keep going. Redux Essentials. Let's try a log rocket blog. How about NPM? Does NPM have a web interface? It must, right? Redux. And I bet this, yeah. Okay. Good. Excellent. Okay. So it seems really straightforward, relatively simple, relatively small. But Maybe it's not. Maybe these are gigantic files. Who knows? Okay, so createStore. Let's look at createStore. This should be simple. createStore is going to import some stuff, such as a store enhancer. Did I see the store enhancer? Oh, these are from types/store. Okay. And we've got a big deprecated block. We're deprecating, I guess, an old createStore function. We recommend against using the configure store method. Oh, I guess it's the configure store that's deprecated. But is there a non-deprecated version? Let's look at this version, even though it's deprecated. It looks simple. So createStore is parameterized by a bunch of stuff. I think, right? Yeah, okay. I think this is TypeScript, right? createStore.ts. So I believe that this syntax means it's parameterized by things, like in Java. And we've got an S, an A that extends an action, which I guess is essentially some action type, an Ext, which extends the empty object, and state Ext, which extends the state object, I suppose. And what is the function going to do? It's going to, oh, I guess these must be the arguments. It's going to take a reducer, which has type of reducer from S to A, or reducer parameterized by S and A, where S, I guess, must be the state, and an A must be an action. So if I'm reading this correctly, what can something of this type do? Well, it's going to do something where it's going to take the current state and the action, which I'm thinking of essentially as a diff, but might be really a command, and it's going to apply the command or the diff to the state. So this is the thing that, for example, in the Kubernetes world would be like an actuator. All right. And then it's going to, okay, so it takes a reducer. It's going to take an enhancer. I'm not sure what an enhancer is, but it extends store enhancer. It's going to take, oh, I guess it's going to take the two things that extend stuff, whatever Ext is, kind of unmodified, and then we have state Ext, which is presumably going to extend the state. And it's going to create a store, a new store, I guess. We're, or no, rather, it's going to return a store. I guess it's going to return the modified store, right? Because we're still looking at just the type signature. And the store is going to be parameterized by the state and the action in the state extension. And whatever and Ext is doing, I'm not sure, but that's fine. Here's another createStore function. We take basically the same stuff, except we also have the preloaded state. So maybe this is some sort of optimization. And we're going to give it the reducer again, the preloaded state, and an enhancer. It's going to return some sort of state parameterized by SA and state extension. We're going to AND it with the extension. Maybe AND is like a sum type. I'll look this up in a few seconds. And then the function createStore. Do we get an implementation? Yeah. So we're going to check and maybe error out, check some stuff. Essentially type checking, which in my opinion should be done by the compiler if you can, but we're in JavaScript, and I guess you have to do some type checking at runtime. More type checking stuff, and then we're going to return an enhancer of createStore, which I guess createStore is a function, right? So we're passing enhancer, maybe the function createStore, and we're giving it the reducer and the preloaded state. Can I jump to here? I'm not sure. Oh, okay. So this actually only runs if this if block is true, which is in case enhancer is not undefined, I guess, so it's populated. An enhancer is not a function. Oh, sorry. If that happens to me, error out. Where's the corresponding block here? Some if statement. I guess enhancer has to be populated, among other things. Okay, and then otherwise, we set the current reducer to reducer, which is I think what's passed in, right? Huh? And we set the current state to either this must be or, right? To s or preloaded state or undefined equals, I'm not sure, this looks like a Boolean operation. I'll look this up maybe on ChatGPT in a second. And then we're setting current listeners to be some, which has type. Oh, this is the type. Okay, so this is like an or type. It's either a, whatever s state is, the preloaded state, or it's undefined. And that object is going to be just preloaded state as, I don't know what it means to assign the object this or thing, but it's essentially preloaded state or undefined, I guess, if it's not defined, presumably is what that's going to do. And then current listeners is going to be some map from the number to the listener callback. Number might be some sort of ID, and then maybe from that ID we're going to get a callback. At least that's the type, and then we're just going to create a new map, and presumably we're going to populate it. Next listeners is going to be the, I guess, whatever the current listeners is, we're going to create maybe a new listeners object, which didn't we just define it to be the empty map? And we'll set the listener counter to 0, and we'll say we're not dispatching. And then we define some functions. Okay. So where does createStore end? Here's the opening paren. Maybe it ends down. I guess maybe this is the end of the function, and then the stuff I was reading is just like class level stuff. So this is just like standard setup, which is why I guess we're not, dispatching is set to false. Current listeners is and the empty map. So these are just like the standard default values. And then we have this function getState, which if we're dispatching, then we throw an error. You can't call getState while the reducer is executing. The reducer has already received the state as an argument. Pass it down from the top reducer instead of reading it from the store. This is what that comment tells you. And then we're otherwise, if we're not dispatching, we're going to just return the current state as s. I guess the idea of the as s stuff is like s is some type, I assume is what's going on, and that's presumably something that you as the creator of your app are going to have some type that like extends state, and this is, I guess, making sure that the thing that's returned is the thing in your type, presumably. Then we've got some change listener stuff. But before we get too far, just so I don't forget, I said I was going to look something up. And what was it? I feel like I understand this stuff now. I was confused for a moment. Well, one thing I want to know is what a store enhancer is. Redux enhancer example. Okay, so let's look at the document. A store enhancer is a higher order function that composes a store creator to return a new enhanced store creator. This is similar to middleware in that it allows you to alter the store interface in a composable way. Store enhancers are much the same concept as higher order components in React, which are also occasionally called component enhancers. Because a store is not an instance, but rather a plain object collection of functions, copies can be easily created and modified without mutating the original store. It's some way to extend stores. I'm not really sure. It sounds like it's equivalent or similar to a bunch of other things you have of extending functionality. So this, I feel like in the JavaScript world, it's very common to have like a bunch of different ways of doing things. So maybe this is not really fundamental to understanding Redux. Maybe it's more about like, this, by the way, you can also do this if you need more flexible functionality. So I'll just assume that that's just about flexibility and kind of ignore it. The other thing that I think I was confused about was the or statements, which I think I've decided is about the type signatures. But let's see, TypeScript or an and. Unions and intersection types. Yeah, okay. Occasionally. Is this right? Do I see ors? Let's read about it anyway. Occasionally, you'll run into a library that expects a parameter to be either a number or a string. You shouldn't do that. But I guess in JavaScript, you have to do that. Right, that's fine. For example, this. Takes a string and add padding. If padding is a string, then the padding is appended. If it's a number, then that number of spaces. So padding is any. So I guess this is a replacement for the any type. Let's see. Yeah, here we go. Padding string or number. Okay, great. And that must be the intersection type. Oh, I see. Intersection types are closely related to union types, but they are used very differently. An intersection type combines multiple types into one. This allows you to add together existing types to get a single type that has all the features you need. So this is like, I guess maybe in Java would be like it implements a bunch of interfaces. So you have to implement the person and the serializable and the loggable interface. And that's that. I'm actually not sure if intersection type is a general thing. There must be some notion, intersection type. It can be assigned to both the types sigma and tau. Wait, why is this not dark? Oh well. Sorry for those of you who prefer dark. That I'm sure was an unwelcome blast of light, and I apologize. Okay, so now that we know what's going on with those types, and if you are a TypeScript person, you probably were well aware what's going on with those, but I wanted to check it out to make sure I knew how to read the code. So you can do things like replace the reducer. Dispatch is probably pretty essential, unless it's deprecated. Dispatch is an action. It's the only way to trigger a state change. The reducer function used to create the store will be called with a current state tree and the given action. So when you dispatch, we're going to call reducer, which I think is something that you as a user have passed in. And it's going to call some stuff. Hang on one moment. So honestly, I can't tell if I'm streaming. I'm guessing I saw one YouTube window told me I was, and now YouTube seems to think I'm not. So I'm obviously having some technical difficulties. I apologize. Let me see if I can. Let me see if I can remedy this at all. All right. Hello, everybody. I am so sorry. The window I have told me I was streaming. I just changed basically everything on my machine, including the operating system, and among other things, OBS changed, and it's behaving differently. And I thought that I had told it to go live, but I think it was just in like demo mode. So I apologize. I recorded already a bunch of stuff, so that you'll be able to see that when I post the video. Apologies there. I think I'm actually live now. Let me double check this by clicking on my channel and verifying. There we go. Okay. So sorry about that. That's a bummer. So I apologize to those who are waiting. But to recap, where we were is we started looking at the createStore function. This is really the first file that we've been looking into. I spent some time, I guess, looking at the general idea of how we expected Redux to work and what it's used for. The gist being that it is used for managing state in JavaScript apps. It's frequently used along with React. And what we've seen so far is essentially just that we're going to create this store where a store is going to be the object that stores the state, and we're going to pass in reducers. We haven't looked really at reducers yet, but right now we're looking at the dispatch function. Okay, so the dispatcher function dispatches an action. It's the only way to trigger a state change. The reducer function used to create the store. So the reducer will create the store. And so I think that the way to think about this is that it's called an action. So it's probably more akin to a command or a function. There seems to be a lot of analogy with functional programming. I think there is some, I think this was made at Facebook, right? I think that there is functional programming at Facebook. I think they use OCaml, among other things. I don't know how direct the lineage of influence is, but they're thinking of this as dispatching an action. I'm going to take maybe like more of a control theory perspective and think of it essentially as dispatching a diff. So this is you're going to emit kind of news items like headlines, like a news wire, and then when that's dispatched, that's going to trigger a state change, and there's going to be a reducer function that's going to create the store, and the store is the state if I understand it correctly. And when the state changes, everything that's subscribed to the state will eventually change. And by eventually, I mean maybe in a few milliseconds, maybe in a couple seconds if things are slow. But that will be kind of spread out through subscribers to the state, to the store or the state or whatever they call it. And so the reducer function is similar to what we've seen in Kubernetes and probably a few other places, where you have the current state of the world and you have the desired state of the world, and there needs to be some sort of actuator in that loop, and I believe that that's what the reducer is doing. So let's take a look and see if that's correct. So the reducer is going to create the store, and the store, I'm thinking at least conceptually, is the new state of the world, and it's going to be called with the current state tree. It is the current state and the given action, which is in my thinking here essentially a diff. It's essentially where do we want to go, a vector. And its return value will be considered the next state of the tree. Yeah. And the change listeners will be notified. Okay. And so the base implementation only supports plain object actions. If you want to dispatch a promise, an observable, a thunk, or something else, you need to wrap your store creating function in the corresponding middleware. Okay. So really, we're going to only support basic objects. And then you have to have some sort of middleware that you're going to write yourself, or maybe there's like a bunch of middleware libraries, and they handle common cases or whatever. So for example, the Redux thunk package will handle thunks. I was not really aware that JavaScript had thunks, but I guess they do. And the action A is a plain object representing what changed. Yes. Okay. So what changed, in my opinion, is not really a function. It's more like a diff. It is a good idea to keep actions serializable, so you can record and replay user sessions, or use the time-traveling Redux dev tools. Yeah, okay. So similar to like event-driven development, I guess, or event databases, if you keep a log of them, you can replay. An action must have the type property, which may not be undefined. So it can't be an undefined type. And for convenience, we're going to return the same action object you dispatched. Is that convenient? Don't you already have it? I'm not sure why, but you might need to, you might want that. Okay, so dispatch is going to take an action. And if it's not a plain object, we're just going to error out. If we're undefined, we're going to error out and do a bunch of more type checking. And then we're going to try, this seems to be maybe the real meat here. We're going to set is dispatching to true. There doesn't seem to be any like locking or whatever. So I'm not sure how threading or thread safety is handled here. And then we're going to set the current state to be just calling current reducer on the current state in action. And then finally, we're going to set dispatching to false. And then we're going to get the listeners where next listener, we're also, I guess, as a side effect, setting current listeners to be equal to next listeners. And then we're going to loop over them with this for each loop. And we're just going to call listener. So I guess listener is a function. And then we're going to return the action we sent in. Now, the question I have is, where did current reducer come from? This is dispatch, right? So current reducer must be somehow set. Let's see if we can find this function. So current reducer is, yeah, it was set here to whatever reducer is. I guess when you created the store. Okay. So we can also add a change listener. This is subscribe. This should, we have just some list of listeners. I forget exactly what type it is, but some list or map that we can iterate over. And I presume listener is subscribed is just going to add the listener, but let's see if that's the case. Adds a change listener. It will be called anytime an action is dispatched, and some part of the state tree may potentially have changed. You may then call getState to read the current state tree inside the callback. You may call dispatch from a change listener with the following caveats. Okay, 1, the subscriptions are snapshotted just before every dispatch call. Okay, maybe we could find out where that happens. If you subscribe or unsubscribe while the listeners are being invoked, this will not have any effect on the dispatch that is currently in progress. However, the next dispatch call, whether nested or not, will use a more recent snapshot of the subscription list. Okay, so we're just going to make a copy, I guess, of the current state before we dispatch, just so that things presumably are not in an undefined or unpredictable state. But then, you know, that dispatch call might, I guess, itself have a sub call to dispatch, and that sub call will not use the snapshotted state. And the listener should not expect to see all state changes, as the state might have been updated multiple times during a nested dispatch before the listener is called. Okay, so I guess we keep calling dispatch until, and then listeners are called at the end. I thought we just looked at dispatch and it called listener, all the listeners. But maybe there's some monkeying about with the listeners that I'm missing. It's however guaranteed that all subscribers registered before the dispatch started will be called with the latest date by the time it exits. Okay, cool. All right, so subscribe, we're just going to pass in this this function, avoid function, and we're going to do type checking. And if we're dispatching, we're going to throw an error. You can't call store subscribe. And then otherwise we set is subscribed to true, which I guess is a property of the store. And ensure can mutate next listeners. I don't know what that means. We get a listener ID, which is just the next listener ID counter. I don't know what happens when this rolls over. And then we set, or maybe it can't in JavaScript. I'm not sure. Then we set next listeners dot set listener ID to listener. The listener ID. Oh, okay. I think next listeners is a map, right? So we're adding to it the pair listener ID and listener, I think. And then we're going to return the unsubscribe function, which if we're not subscribed is a null op, a no op. And otherwise, we first say that we're not subscribed, and then we delete the listener. Which, is that right? It seems like if it fails here, then your listener is subscribed but thinks it's not. Maybe you should finish deleting it before you say you're not subscribed. Not sure. Okay. So all of that is like straightforward. This is it's all really rather nice and straightforward. We can replace the reducer. Replaces the reducer currently used by the store to calculate the state. You may need this if your app implements code splitting and you want to load some of the reducers dynamically. Okay. And we have observable reactor libraries. I don't know what that is. Maybe that's a common library thing. I'll ignore it. And then we have an init action, which is dispatched, I guess, when the store is created, so that every reducer returns their initial state. This effectively populates the initial state tree. Okay. And then we've got legacy createStore, which I will ignore. And we had some deprecated stuff at the beginning, which I think I did not quite ignore. But I suppose if you are a Redux programmer, you may want to be aware that it's deprecated. So here's compose. I think compose said it was going to, wait, no. Combine reducers is what I'm thinking of. I'm not sure what compose is doing. It composes as single argument functions from right to left. So this is just function composition, I guess, which maybe JavaScript doesn't natively have. All right. Function composition. Fair enough. And then reduce is going to take, I guess, a lambda of 2 arguments and just apply them together. And compose will maybe take any number of functions. If the length is 0, then we're just returning the one function. If the length is 1, we just return, I guess, the function at the top. Otherwise, we're going to return funcs reduce. Okay, so this is the reduction thing. This is essentially like we're doing like a fold. And this is kind of like applying the fold, which is just compose 2 functions. And somehow they're going to propagate that over, I guess, an arbitrary amount of functions, I think is what it's trying to do. All right, combine reducers is going to presumably combine some reducers. So let's think for a second about what this would look like. The reducers, on my understanding, are going to take the current state of the world, the desired next state, and produce and make the relevant changes to achieve that desired next state. And so if you have 2 reducers, assuming there's only one state of the world, I'm not really sure what they're going to do. Maybe one reducer might fail and the next reducer might be the callback, or maybe they need to be executed in order. I'm not sure if there's a convention or if you can combine them in different ways. I guess let's take a look at and see what they do. So first we check, wait, hang on. What's the actual function? Get unexpected state shape warning message. Okay. So there might be some unexpected state shape, which I'll ignore. We see something about reducer shapes. So I'm wondering if reducer shape is really about kind of the idea that you could combine reducers in different ways. Here's combine reducers. Whoa, why does it keep doing that? I'm not sure. I guess because I clicked on it. So it's parameterized by m. I'm not sure what m is, but we'll see in the comment. Seems like a relatively simple implementation. So combine reducers turns an object whose values are different reducer functions into a single reducer function. It will call every child reducer and gather the results into a single state object whose keys correspond to the keys of the past reducer functions. So I'm guessing maybe keys are a way to tell reducers what their scope is. You're in charge of these sorts of state, these bits of state. And this is maybe going to partition the reducers so that they do their thing and their jobs are brought together correctly, I think. So the template is templated on S, a combined state object type, and we've got reducers, an object whose values correspond to different reducer functions that need to be combined into one. One handy way to obtain it is to use the ES6 import as reducers syntax. The reducers may never return undefined for any action. Instead, they should return their initial state if the state passed to them was undefined and the current state for any unrecognized action. They should return their initial state if it was undefined. Okay. The state was undefined. That way, the state is undefined, I guess everything is going to return the same thing, which is just the current state. Sorry, the initial state. And otherwise, if it's an action that's not undefined, but they don't recognize it, I guess, which means that they are not like registered to handle that sort of action, they're going to essentially ignore it by returning their current state. And I guess that the diffing operation, under the like diffing operation, the current state is essentially like the identity, right? So I guess that seems to work out. Then it's going to return a reducer function, a single reducer function that invokes every reducer inside the past object and builds a state object with the same shape, whatever shape is. So M, I'm not sure what M is. And I don't know what M key of M is. It's going to, at any rate, it's going to extend a reducer of any, or undefined. I'm going to sum up a bunch of type stuff. And I don't know what never is. But do we see an implementation? Here's the export default function. We're going to get the reducer keys. So the reducers have some keys, and that is maybe like a namespace. You can imagine the state is divided up into namespace, and so each reducer has its own namespace or whatever. And then we set the final reducers to be, we're going to iterate over the keys and just grab the current key so that we don't, I guess, have to keep typing up the indexing. And we might, if we are not in production, we will emit some warnings about undefined, I guess, reducers. And if we are in production, then we won't do that. But we'll take a look at the reducers. Okay, so this is just type checking, making sure the reducers are functions. And then down here, we could actually get the final reducer keys. And then let's see. This is used to make sure we don't warn about the same keys multiple times. All right. We've got this shape assertion stuff. We're going to, this is just more error checking, it looks like. Try assert reducer shape on final reducers. But have we done anything? Combine reducers. I'm not sure. Do we return anything? Maybe assert reducer shape return something? I'm not sure. Where did combine reducers go? I guess this is just closing the try block, right? So we're not at the end of the function. Here's the return. I just missed. I saw function combination and I just missed the return. Okay, there we go. And AU is saying I should join Twitch. I'm actually on Twitch. I've been ignoring Twitch for a while, but I'm starting to do more stuff on Twitch, I guess, as of like yesterday again. So I'm on Twitch. You can check me out there. And I should be on there, I think, for most of next week, assuming that nothing catastrophic happens. Okay, so the return function, we're going to return the combination, which is what I was looking for. The state is state from reducers map object, and some action. We check the assertion error. We check if it's production. I just want to see where they combine the reducers. Okay, so here we go. This should be it. So we're going to iterate over the reducer keys, and previous state for key is equal to state at key. So we've got some list of state indexed by keys. Next state for key is we're going to call the reducer of the previous state for key and the action. Where did reducer come from? Reducer is just set to the final reducers at key. And if the type is undefined, we do some erroring. Otherwise, we set next state at key to the next state for key. And then we set has changed to either the existing has changed, or I guess checking whether the next state for key is equal to the previous state for key. Okay, so that's about as simple as it can be. There's a bunch of stuff. I'm not sure in JavaScript, for example, we define some const variables that don't really seem to be, strictly speaking, necessary. I don't know if that's an optimization for performance, or if it's an optimization for like making the code easier to read. But other than that, we're really just getting, we have a list of reducers, a list of keys, and we're looking up or maybe a map from key to reducer and a map from key to state. And we are just getting the reducer for that key and applying it to the state for that key. And then the state is essentially just some kind of like disjoint union over the state for the different keys. So that's straightforward to at least conceptually. I'm sure that there are foot guns if you're using it or whatever. Okay, here's apply middleware. Now that we've seen a little bit about what's going on under the hood, middleware should be about, among other things, adding support for more complicated types than like the plain objects. I think is one way, one place where it said that we might use middleware. So we have this function, apply middleware, which is of type store enhancer. So it's going to enhance your store. It's going to create a store enhancer that applies middleware to the dispatch method of the Redux store. We looked at dispatch. This is handy for a variety of tasks, such as expressing asynchronous actions in a concise manner, or logging every action payload. Okay, so we can basically just listen in on the stream of events and possibly do other stuff. And here's store.typescript. This should be the actual store, right? We have this dispatch thing. What? All right, whatever. We have this dispatch thing, which is a dispatching function, or simply dispatch function. And it's a function that accepts an action or an async action, and may or may not dispatch one or more actions to the store. Okay, so this function is going to take an action, and it may also dispatch another action. We must distinguish between dispatching functions in general and the base dispatch function provided by the store instance without any middleware. The base dispatch function always synchronously sends an action to the store's reducer, along with the previous state returned by the store. The base function is always going to send an action to the store's reducer, along with the previous state returned by the store, to calculate a new state. But why do we need to dispatch it? Why do we need this dispatching function if I thought this was already handled. But let's move along. It expects actions to be plain objects ready to be consumed by the reducer. Middleware wraps the base dispatch function. Okay, so middleware is just going to wrap this function and allows for dispatching. Okay, so this function should be really simple, right? I think its main goal is to be a bit in the code where you can extend functionality. We've got some observable stuff with subscribe and unsubscribe stuff. More observable. An observer is used to receive data from an observable, and it's applied as an argument to subscribe. I'm not sure. Let's see. Is observer something that's existing in other JavaScript libraries? Or are they, utils symbol observable? Maybe this is the definition of the observable. Export type observable. Okay. A minimal observable of state changes. So what do we have? We've got subscribe, which is, I believe, similar. We saw subscribe in the other file. I'm not sure if this is the same subscribe. It basically adds you to a list of callbacks. Next is used to receive data from an observable, and it's applied as an argument to subscribe. So when you subscribe, you, I guess, apply the next function. Is that right? And then you can use that to get, I guess, data out of the observable. So then here's the store. A store is an object that holds the application's state tree. Yeah, so I guess the thing it holds is a tree rather than like a flat, object of JSON data or whatever. There should only be a single store in a Redux app, as the composition happens on the reducer level. Yeah. So there's only one database essentially, and then you combine things by describing how the database is going to change in response to actions, which is the reducers.
So we have we're parameterized by S, the type of state held by the store. And there's only one store, right? So there must be one S that rules the Redux app. A is the type of actions which may be dispatched to the store, and state X is any extension to state from store enhancers. And what do we have? You can dispatch an action. Dispatch as an action is the only way to trigger a state change. Yeah. Okay. So you call, your job as the app creator, I guess, is to create the appropriate actions and call dispatch at the appropriate time. I guess. I think this is application writer facing and not just under the hood stuff. The reducer function used to create the store will be called with the current state tree and the given action. Its return value will be considered the next state of the tree. And then again, we only support plain stuff. You can extend it with middleware. Okay, so dispatch function, we can get the current state. We can subscribe or unsubscribe. This adds a change listener. It will be called anytime an action is dispatched. You can call dispatch from a change listener with the following caveats. Okay. So we can replace the reducer, which we saw in interoperability for observable/reactive libraries. Okay. So there are other ways to do observables, I guess, and reactive programming. And this is, I guess, like a way to shoehorn together apps that essentially, I think, implement the same pattern, but maybe with little differences, and people have preferences about which library they use. And so I think this is just like a convenience compatibility thing. And AU is saying chaining of dispatches. Yeah, I'm not sure where I was looking when you were saying that, but yeah, I think that's probably right. I can leave this up so I can see it better, but let me maybe make it a little bit smaller. All right. Then we have the store creator. A store creator is a function that creates a Redux store. Like with dispatching function, we must distinguish the base store creator, createStore, exported from the Redux package, from store creators that are returned from the store enhancers. Okay, so this is the base store creator. Did I not already look at this stuff? I'm not sure. But we're going to create the store. We have a store enhancer. Okay. All of this stuff is straightforward, I think, given what we've already seen. So I'm not going to look too much more closely at it. Oh, this is types. I see. Was I looking at type store? Okay, yeah, we had looked at store. That's why that all seems so familiar. I was a little bit surprised that there was so much repetition. However, the comments here are useful. I think if I were to do this again, I would first look at the types file, maybe, and then look at the implementation. So here's reducers. I think we looked at reducers before. Let me see what the source directory is. Well, no, we looked at createStore. That's what it was. Okay. So we haven't looked at reducers. Let's look at reducers. What can we do? A reducer, also called a reducing function, is a function that accepts an accumulation and a value and returns a new accumulation. They are used to reduce a collection of values down to a single value. And Jasbir Singh is saying, great work, answer ever. Thank you very much. I appreciate it. The reducers are not unique to Redux. They're fundamental concept in functional programming. Yeah. They are fundamental to functional programming. Again, one of the ways I think that I look at the world that I think is useful is from what I've been calling the control theory perspective. And that's how I think that's how I would have pitched this library, or marketed the library, as opposed to leaning on the functional aspect. Although at the time, I think functional programming was hot, so this probably helped sell the library. But rather than the functionalness, I think is not so essential. I think the really essential thing is there's a state of the world. There are there's current state, where you are. If you're like driving your car or whatever, there's where you want to go to, which might be, the beach or wherever. And then there's some change you have to make to get closer to the beach. In this case, every action is essentially like a thing that points in the direction of the way that you want the world state in your app to be.
and the reducer's job is to take the old state and new state and to produce the new one. That's more my mental model than the functional programming model, as much as I do love functional programming. Okay, so in Redux, the accumulated value is the state object, and the values being accumulated are actions. Reducers calculate the new state given the previous state and an action. They must be pure functions, functions that return the exact same output for given inputs. So, for example, I guess you can't have a random number generator in your function, but you probably could take a random seed. It's a function of if you take the random seed as input, then you can write a pure like randomized function in a sense. Okay. All right. So reducer, we basically have a sense of how it works because I think we've looked at it. It's going to take a state and an action, and it's going to return this thing that's either a state or a preloaded state or undefined. Let's say reducer's map object whose values correspond to different reducer functions. And it's keyed by what? State? Key of preloaded state. So the combined preloaded state of the reducers, the combined state of the reducers. Preloaded, maybe, is that the initial state that your app starts with? I'm not sure. And then we have the type of actions that the reducers can potentially respond to. So I'm guessing if this is the type of action the reducers can potentially respond to, then this should be essentially a map keyed by action type, so that when we receive an action, like make text bold or whatever, we should be able to look up in constant time what are all the reducers that can respond to text bolding or whatever. So I would expect that this is a map keyed by A, but it seems like we're seeing key of S. So I'm not sure exactly what's going on. So A extends A, key of preloaded state extends key of S. And we've got key in key of S, K in key of S. This looks like maybe set builder notation. Then we're going to call, and this is of type reducer of S of K, A, K extends preloaded state. This is just some type thing. And this is a, this is just a type. So maybe somewhere we will see that it does some sort of lookup with A. I'm not sure. State from reducer's map object of M. M is an object map of reducers as provided by combined reducers. We saw combined reducers. We've got a bunch of reducers. We can combine them. That gives you some of the compositionality that they're talking about with the functional programming stuff. These are just type definitions again. So I guess we don't really get implementations. I'm not sure. I'm not a TypeScript person, but this all just seems to be type information. And that would, I guess, stand to reason. Actions from reducers, etc. Okay. Is there a way to click through to the implementation? Action from reducers map object. Can I search for the symbol? No. All right. Well, whatever, man. So let's move along. Here's middleware. I'm going to skip the middleware types. And actions. We'll just see quickly if there's anything especially interesting in actions. An action is a plain object that represents an intention. Here we go. It's intention. This is the signal that we're doing something like control theory to change the state. Actions are the only way to get data into the store. Any data, whether from UI elements, network callbacks, or other sources, such as WebSockets, needs to eventually be dispatched as actions. Actions must have a type field that indicates the type of action being performed. Types can be defined as constants and imported from another module. These must be strings, as strings are serializable. Well, elsewhere they told us that actions should be serializable. I don't know if strings are the only serializable things. This seems like this is this doesn't seem to be to logically hold. They may have to be strings, but this argument is not a valid logical argument. Okay, other than type, the structure of an action object is really up to you. If you're interested, check out Flux Standard Action for recommendations on how actions should be constructed. Why Flux Standard Action? Aren't we in Redux? Okay. So we've got this type. It's going to extend T extends string. This needs to be a type, not an interface. Okay. We've got unknown action, which extends action. An action type, which accepts other properties, which is any action. And it's got extra property strings. Then we've got action creator. An action creator is, quite simply, a function that creates an action. Do not confuse the two terms again. An action is a payload of information, and an action creator is a factory that creates an action. Calling an action creator only produces an action, but it does not dispatch it. You need to call the store's dispatch function that actually calls the mutation. Sometimes we say bound action creators to mean functions that call an action creator and immediately dispatch its results to a specific store instance. If an action creator needs to read the current state, perform an API call, or cause a side effect, like a routing transition, it should return an async action instead of an action. All right, so you have action creators. All right, cool. I think that's basically all of the things. Is there anything else? We have scripts, which I'm not going to look at. Examples are, I think, worth looking at if you are interested in using Redux. But there's so much well done like documentation on Redux that I don't think it's going to be the most useful thing for me to look at the examples. The website just seems to be the website, and that seems to be it. Yeah, so that's Redux. It's relatively simple. I think when I first heard about Redux, I built a similar framework, just kind of like hacking around to see. I think I was working in Java or Kotlin, and I just wanted to see if there was a way that I could build something Redux like that solved the problem I was having. And it's not so hard. There's not a lot to it. I think that probably what Redux gives you is first of all, it's going to be performance, the accumulation of the everyone kind of using the same library and very smart people making this library is going to mean that the wisdom of everybody is going to be kind of funneled into it, and so you're going to get a like high performance, relatively easy to use version. Although typically you find as you get like past version 1 or whatever, people realize that there are extensions needed to the frameworks and they become a little bit more complicated, and so you're going to get some like, I don't know how Redux is to use. I imagine there are some people who find it rather complex and confusing to use, even though I think conceptually it's a bit straightforward. So that's Redux. That's all for me. I will be returning next week to do one of these code reading videos, either on Monday or Friday. I haven't quite decided yet, but I'll put it up. I'll put up the schedule before, at least the day before. And I've been away working on some other stuff, and doing other things that are outside of the internet world. But the goal is starting next week to have more of a daily streaming schedule. But most of those days are going to be about code writing. And I have to think of a new thing to call the code writing, because I realized that there's somebody who does Haskell that does some sort of coding adventure thing, and I've been calling the most recent episodes Adventures in Coding, and I don't want to kind of have a name clash or step on anyone's feet. So I'll figure out what to call it. If you have any cool names for a live coding video series, let me know. But I'll be doing most of the live coding on Twitch, in the expectation that it'll be a little bit more like the videos of people who play games for 4 hours, where there might be some dead time, or it might be take me a while to debug, and that will let me keep the code reading videos like tighter and focused on the existing YouTube presence. Did the stream crash? Yes, the stream did crash. Like I said,
or it's like buffering. I haven't had this problem before on YouTube. I suspect that it's related to the changes I made. So it may take me a little bit to debug. I'm going to go ahead and post the recorded version of this video and take down the live version, or make it what's the word? Make it non-public, and that way you'll get the better version. But I'll try to figure out what is actually going on with the OBS to YouTube connection, and see if I can fix that by the next time I do the streaming to YouTube. All right, that's all for me. Thanks for watching. Have a good weekend.